data of behavioral kind of a data, when you do not have a very objective, and so all these measures like we were talking about in our earlier classes, data like concepts like leadership, motivation, engagement, risk-taking behavior, these are all perceptual behavioral variables. In that case, you should use structural equation models. Yes, Kunjal?
Sir, I have a doubt.
Yes, go ahead.
In the chi-square, we typically in this particular test, we want the sample-based data to be equal to the model data. That means there should be no difference.
No difference.
Yeah, if I'm failing to reject the, yes, correct, sir. So we fail to reject the null hypothesis.
We fail to reject the null hypothesis.
Yes. That means we are accepting.
We never write we accept the H naught.
Yes.
We always say we fail to reject. That means our chi-square is 0 for the given degrees of freedom, which implies that the S minus sigma is 0, which means that the sample matrix, that is the original data and the recreated data based on the model, are superimposing, which therefore will mean that a model is a very good representation of the reality.
Okay, sir.
Yeah.
Thank you.
Yes. Yes.
Sir, F1 has got the outcomes I1, I2, I3, and F2 has got outcomes, reflected outcomes I3, I4, I5. There is a path beta which is connecting in the model.
Yes.
You can highlight that.
So this is the regression path. This is the regression path. Okay. So basically what we are saying here is that F2 is going to be derived based on F1. That is that correct? So what you will have, see here in this equation, I have written F2. Correct? Okay. And what is F2? We can say F2 is equal to nothing but beta F1 plus some structural error. So there will also be a structural error. Okay. So beta times F1. So it is like a regression equation. Y is equal to beta times X plus residual of Y. So essentially this I5 or I4 and I6, they are going to be derived based on F1 and F2. F1, because F2 is in turn derived from F1. So essentially everything is going to be derived from the independent factor, which is F1. So this path is actually showing that there is a regression or there is a causal path here, which we are also estimating in our structural model. Does that?
Thank you.
Yeah. Yes. Any other question? Okay. So in that case, let us stop here. We'll take a break. Okay. And